Hello my dear children, from chapter number 11, Human Eye and the Colorful World, we have covered all the topics. We have also taken the recap of the topic by going through the textbook. Today we are going to discuss the questions from the exercise which is given at the end of this lesson. So to get the feel of actually you are reading through the exercise, I have given the heading from the textbook, so please have a look at that. Question number 1, 2, 3 and 4, these are multiple choice questions which are very important, and let me just make it very clear to you dear children that in the final exam our paper has multiple choice questions. So to get the practice of this, it's very necessary that you should know how to answer it and how to think for the correct option from the given question. So let's begin with question number 1. The human eye can focus objects at different distances by adjusting the focal length of eye lens. This is due to. I hope you could guess the answer. We have learned one term for that. The tendency of the crystalline lens to adjust its focal length is called as. And the options are presbyopia, accommodation, nearsightedness and farsightedness. And the obvious answer is accommodation. Question number 2. The human eye forms the image of an object at its. I told you it's called as the screen of your eye. And what is the screen of your eye called as? Cornea? No. Iris? No. Retina? You can think of. Pupil? A big no. So the answer is the retina is the place where the human eye forms the image of an object. Question number 3. The least distance of distinct vision for a young adult with normal vision is about. Options are 25 meter, 2.5 centimeter, 25 centimeter, 2.5 meter. So least distance of distinct vision, which is also called as the near point of our eye, and it is very clear answer, and the answer is 25 centimeter. Its meaning is if you hold the object before 25 centimeter very close to your eye, you will not be able to see that object clearly because the ciliary muscles has got certain limitations. Beyond certain limits it cannot contract, and so the minimum distance at which you can see the object is 25 centimeter, which is called as least distance of distinct vision, or it is also called as the near point of our eye. Next question is, the change in focal length of an eye lens is caused by the action of. Which part of your eye is responsible for changing the focal length with the help of eye lens? You have to think over it. Options are pupil, retina, ciliary muscles and iris. So the function of eye lens is to adjust its focal length. But for doing it, something is keeping the eye lens intact, and the answer is ciliary muscles. Alright, so one option you have to think and check out. First ruled out, okay, this cannot be, and then select the correct answer. So from the chapter only 4 MCQs are given, but there can be many MCQs. For that you have to read the lesson in details so that any questions which come across you should be able to answer. Okay. Moving to the next question, question number 5. A person needs a lens of power minus 5.5 diopter for correcting his distant vision. For correcting his near vision, he needs a lens of power plus 1.5 diopter. What is the focal length of the lens required for correcting the distant vision and the near vision? We are asked about both. Now one thing we are aware that power of lens is given by the formula 1 upon focal length, and the focal length should be in meters. Alright. So since we have to find out focal length, our formula would be Focal length is equal to 1 upon power of lens. We will consider focal length in meter and power of lens in diopter. Now we are given the power of lens for both, for distinct vision and for near vision. So let's consider one by one. Let's talk first about the distant vision. So power of lens for the distant vision is given to us as minus 5.5 diopter. We have to find out the focal length. So our formula for focal length is equal to 1 upon power of lens. So substitute the values, 1 upon minus 5.5. Let's take out the decimal point. So it will be minus 55 upon 10 and the 10 will go into the numerator. So it is minus 10 upon 55. Reduce it to lower term. 5 2s are 10, 5 11s are 55. So minus 2 upon 11. And if you actually divide this, our answer is minus 0.1818 meter. But when we write the answer, we have to convert this meter into centimeter. So we have to multiply this by 100. So minus 0.1818 into 100 centimeter. So our answer is minus 18.18 centimeter. And the nearest approximate answer is minus 18.2 centimeter. You can leave your answer at minus 18.18. Alright, so we got the answer negative. The focal length of the lens required for the correction of distant vision is minus 18.2. And since we got the focal length negative, meaning is that the lens which is required is concave lens, because focal length of concave lens according to sign conventions is negative. Alright, let's solve now for the near vision. We are given that the power of lens for the near vision is plus 1.5 diopter. Let's use our formula. Focal length in meters is equal to 1 upon power of lens. So 1 upon 1.5. Again, let's take out the decimal point. So 1 upon 15 by 10, take 10 into the numerator. So we get 10 upon 15. Reduce it to lower terms. So we get 2 upon 3, and 2 upon 3 is 0.667 meters. Let's convert this into centimeter. So we have to multiply it by 100. So 0.667 into 100 centimeter. So our answer is 66.7 centimeter. So we can write like this. The focal length of the lens which is required for the correction of near vision is 66.7 centimeter. And since the focal length is positive, so can you guess which type of lens is used here? The positive focal length is for convex lens, hence the lens is convex lens. Alright, so simple, we are given the power of the lens, and with the help of the formula we have to find out the focal length of both the defects. Alright, let's move to the next question now. Question 6. The far point of myopic person is 80 centimeter in front of the eye. What is the nature and power of lens required to correct the problem? Now we are given that the far point of the person is 80 centimeter. Its meaning is the person is not able to see beyond 80 centimeter. Now see, for the normal human being, the far point is infinity. But for the person who has myopia, his far point is 80 centimeter, means he can see the object only if it is up to 80 centimeter distance. Now the type of lens which should be used to correct myopia is concave lens. This we are aware, okay, since we are given that the person has a myopic eye. Now to find the power of the lens, we need to first find its focal length. Alright, so to find the focal length, we have to make use of lens formula. if you are making use of lens formula, we should know object distance and image distance. Now object distance, you know, it's denoted by letter U. Object distance is infinity, but if we form the image of the object at 80 centimeter, then the person will be able to see that object. So we will write the image distance as 80 centimeter. But since the image is made in front of the lens, therefore the image distance will be negative. So we will take V is equal to minus 80 centimeter. Alright children, so U is infinity because the object is at infinity for the normal human being. The far point, or the far point of the eye is infinity, and image is minus 80 centimeter. Now let's use the lens formula. 1 upon F is equal to 1 upon V minus 1 upon U. Substitute the values. 1 upon F is equal to 1 upon minus 80 minus 1 upon infinity. But 1 upon infinity is 0. So we get 1 upon F is equal to minus 1 upon 80, and therefore F is equal to minus 80 centimeter. Alright. So, but focal length should always be in meter. When we will be using the formula P is equal to 1 upon F, F should be in meter. So F is equal to minus 80 upon 100 meter. So you can cancel out 1 0. So we are left with minus 8 upon 10 meter. Reduce it to lower terms. So minus 4 by 5 meter. To find power of the lens, let's make use of the formula. Power of lens is equal to 1 upon focal length in meters. So 1 upon minus 4 upon 5. Let's reverse the ratio. Take 5 in the numerator. So minus 5 upon 4, that is equal to minus 1.25 diopter. So the power of the lens is minus 1.25 diopter. Now since the focal length is negative, so which type of lens is used here? It must be concave lens. And we know that myopia is corrected by using concave lens. Okay. So the next sum now, this is question number 7. Question is, make a diagram to show how hypermetropia is corrected. The near point of hypermetropic eye is 1 meter. What is the power of lens required to correct this defect? Assume that the near point of normal eye is 25 centimeter. Now what is given to us? We are given that the near point of a person is 1 meter and it is hypermetropia. Now see, for the normal human being, the near point is 25 centimeter. But for this particular case, the near point is 1 meter. Now since it is hypermetropia, naturally the lens which is used to correct this defect is convex lens. Now near point is 1 meter. Its meaning is that the person can see the object which is placed at 25 centimeter only if the image is formed at 1 meter, because for this particular person the near point is 1 meter. So the person could see the object only if it is at 1 meter distance. So the image of the object should form at 1 meter distance, then and only then the person will be able to see that. So to find the power of lens, we need to find its focal length. Since the object is in front of the eye, the object distance will be negative. So object distance, the near point of the person is 25 centimeters. So object distance is 25 centimeter and it should be negative. So minus 25 centimeter. And since the image we want to make or form at 1 meter distance, because for this particular case, for this particular person, his near point is 1 meter. So we have to make the image at 1 meter distance. The image distance will be negative because it is made in front of the lens. So V is equal to minus 1 meter, that is minus 100 centimeter. So we have to find focal length. Let's make use of lens formula, which is 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon f is equal to 1 upon minus 100 minus 1 upon minus 25. Alright. So see children, this minus minus will become plus. So we get minus 1 upon 100 plus 1 upon 25. So let's take 100 as LCM. So we get minus 1 plus 4 upon 100, that is equal to 3 upon 100. 1 upon f is equal to 3 upon 100. Let's reverse the ratio. So we get f is equal to 100 upon 3 centimeter. But we want focal length in meters. So let's convert this into meters. So f is equal to 100 upon 3 into 1 upon 100. If you cancel out these two zeros, you get f is equal to 1 upon 3 meters. So we got the focal length. So now we can find out power of lens. Let's make use of the formula. Power of lens is equal to 1 upon focal length, but in meters. So 1 upon 1 by 3, we have calculated this. Let's reverse the ratio. So 3 diopter is the power of the lens. Now since the focal length is positive, the lens which is used is convex lens. Alright. So only thing is that you should be able to think what is given. You should be very clear with what is the meaning of far point, what is the meaning of near point. And so solving is not very difficult. So we have done up to question number 7 from the exercise, and only this many numericals are given to us for practice. But for more practice, I will give you more numericals in the form of worksheet, and that I will forward you. But the remaining questions we will discuss in the next video lesson. So till then, keep revising and keep solving and take practice of more sums, so that you will be very clear with any kind of a questions which is coming. So see you in the next video lesson. Till then, bye and take care.